everyone, welcome back to Crit's Corner. In this video, we are going to see about the magnetic effects of electric current. Before getting into the topic, let us know the basics of magnet. A magnet is a material that produces a field that attracts or repels other such materials of magnetic nature. Lodestone is a naturally occurring magnet. It attracts materials like iron, nickel, cobalt, etc. North and South poles. A magnet is always bipolar with poles named North and South poles. These two poles always exist together and cannot be separated. North pole of a magnet is the side which points to Earth's geographic north when it is freely suspended. Like poles repel and unlike poles attract. Similar to charges, poles attract and repel. Like poles repel while unlike pole attracts each other. Now let's get into the video. Bar magnet. A bar magnet is a rectangular object composed of iron, steel or any form of a ferromagnetic substance that shows permanent magnetic properties. It has two different poles, a north and a south pole, such that when suspended freely, the north pole aligns itself towards the geographic north pole of the earth. Magnetic field. The region around a magnet where its magnetic influence can be experienced is called a magnetic field. The direction and strength of a magnetic field are represented by magnetic lines of force. Iron fillings around a bar magnet exhibit the magnetic field lines that encircle the bar magnet. The magnetic field lines can be explained as imaginary lines that graphically represent the magnetic field that is acting around any magnetic substance. Magnetic field lines. Magnets' magnetic field lines result in the formation of continuous running closed loops. The tangent to the field line at any given point indicates the direction of the total magnetic field at that point. The greater the number of field lines crossing per unit area, the higher the intensity, the stronger the magnitude of the magnetic field. There is no intersection between the magnetic field lines. Magnetic field lines for a closed loop. Since magnets have dipoles, magnetic field lines must originate and end. Therefore, by convention, it starts at the north pole and moves towards the south pole outside the bar magnet, and from south pole it moves towards the north pole inside the magnet. Hence, it forms closed loops. No two magnetic field lines intersect. Magnetic field lines do not intersect as there will be no two tangential magnetic field directions associated with the same point, which does not occur. If a compass needle is placed at that point, it will show two different directions of the magnetic field, which is absurd. Relative strength of magnetic field inferred from magnetic field lines. The closer or denser the magnetic field lines, greater is the magnetic field's strength. Magnetic field due to a current carrying conductor. Oersted experiment. When electric current flows through a current carrying conductor, it produces a magnetic field around it. This can be seen with the help of magnetic needle, which shows deflection. The more the current, the higher the deflection. If the direction of the current is reversed, the direction of the deflection is also reversed. Electromagnetism and electromagnet. An electromagnet is an artificial medium which produces a magnetic field on the passage of electric current through a conductor. This field disappears when the current is turned off. The phenomena of producing or inducing a magnetic field due to the passage of electric current is called electromagnetism. Magnetic field due to a straight current carrying conductor. When current is passed through a straight current carrying conductor, a magnetic field is produced around it. Using the iron fillings, we can observe that they align themselves in concentric circles around the conductor. Right hand thumb rule. If a straight conductor is held in the right hand in such a way that the thumb points along the direction of current, when The tips of the fingers or the curls of the fingers show the direction of the magnetic field around it. Magnetic field due to current through a circular loop. The right hand thumb rule can be used for a circular conducting wire as well as it comprises of small straight signals. Every point on the wire carrying current gives rise to a magnetic field that appears as straight lines at the center. Magnetic field due to current in a solenoid. A solenoid is a coil of many circular windings wrapped in the shape of a cylinder. When current is passed through it, it behaves similar to a bar magnet, producing a very similar field pattern as that of a bar magnet. Force on a current carrying conductor in a magnetic field. Ampere's experiment. When an electric conductor is placed in a magnetic field, it experiences a force. This force is directly proportional to the current and is also perpendicular to its length and magnetic field. Fleming's left-hand rule. Fleming's left-hand rule states that the direction of force applied to a current carrying wire is perpendicular to both the direction of the current as well as the magnetic field. Electric motor. Electric motor converts electrical energy into mechanical energy. Current enters arm AB through brush X and current flows through brush Y from C to D. Using Fleming's left-hand rule, we find that the force pushes AB downwards and pushes CD upwards. In an electrical motor, the split rings PQ acts as the commutator that reverses the direction of the current. The reversing of the current is repeated at each half rotation, giving rise to the continuous rotation of the coil. Electromagnetic induction. Faraday's experiment. Faraday discovered that a magnetic field interacts with an electric circuit by inducing a voltage known as electromotive force (EMF) by electromagnetic induction. Moving a magnet towards a coil sets up a current in the coil circuit as indicated by deflection in the galvanometer needle. Electromagnetic induction. The phenomena of electromagnetic induction is the production of induced EMF, electromotive force, and thereby current in a coil due to the varying magnetic field with time. If a coil is placed near a current carrying conductor, the magnetic field changes due to the change in current or due to the relative motion between the coil and conductor. The direction of the induced current is given by Fleming's right-hand rule. Fleming's right-hand rule. According to the Fleming's right-hand rule, the thumb, forefinger and middle finger of the right hand are stretched to be perpendicular to each other. If the thumb indicates the direction of movement of conductor, forefinger indicating the direction of magnetic field, then the middle finger indicates the direction of induced current. I hope you would have a clear idea about magnetic effects of electric current. That's all for today's video. If you are watching my video for the first time, please do subscribe my channel and click the bell icon to notify my future videos. Comment your suggestions in comment section and also leave a comment for what video you are expecting. Thank you so much for watching the video. Meet you again. Bye.